$11. That's what it costs to add a compound to your engine that was, until a few decades ago, mostly reserved for satellite bearings and fighter jet components. And somewhere between the marketing and the mechanic shop, molybdenum disulfide, MOS2, became a $4 bottle promising to save your engine. So which is it? Snake oil in a soda can, or genuinely misunderstood chemistry sitting quietly on a gas station shelf? Here's the problem most people run into. Your engine oil already has an anti-wear additive built in. It's called ZDDP, zinc dialkyl dithiophosphate, and it's been the industry's workhorse since the 1940s. It coats metal surfaces and sacrifices itself under pressure, so your camshaft and bearings don't. It works, but it also depletes over the life of the oil, and modern low-emission formulations have had to cut back on it because zinc and phosphorus damage catalytic converters. So you've got an aging engine, a thinning protective layer, and an oil change interval that keeps getting pushed further apart to save money. That's the gap additive companies are selling into. The pitch is always the same. Pour this in, and your engine runs cooler, quieter, and lasts longer. Sounds great, but here's what almost nobody explains. There isn't one single oil additive. There are at least 4 completely different chemistries being sold under that one label. They don't do the same job. The story of MOS2 itself is worth knowing because it's not a modern gimmick. Molybdenum disulfide has a crystal structure that looks almost like graphite. Flat layers that slide across each other with very little resistance. Metallurgists noticed this decades before it ever went into a car. It got used first in extreme environments, vacuum-rated space hardware, high-load industrial gearboxes, places where a liquid oil film could fail but a solid, layered lubricant wouldn't. Someone eventually asked the obvious question. If it works in a satellite bearing under 0 atmosphere, what happens if you suspend microscopic particles of it in ordinary motor oil? That's genuinely the origin of the modern MOS2 engine additive category. And it's real chemistry, not folklore. The logic is actually simple once you strip the marketing away. Imagine 2 rough metal surfaces sliding against each other under load. A piston skirt against a cylinder wall, a bearing against a crankshaft journal. Oil alone provides a fluid film, but under enough pressure that film can be squeezed thin enough that metal touches metal. MOS2 particles are flat and slippery at a molecular level, so they wedge into those microscopic peaks and valleys and let the surfaces glide over each other even when the oil film gets thin. It's not replacing the oil, it's backup insurance for the moments the oil film is under the most stress. Cold starts, heavy load, high RPM. So why isn't this just built into every bottle of oil from the factory? Mostly economics, not conspiracy. Oil manufacturers formulate to a cost target and an emissions target simultaneously. Adding a meaningful concentration of solid MOS2 particles changes viscosity, can affect filterability, and adds cost per quart across an entire product line sold by the hundreds of millions of gallons. It's cheaper and more predictable for oil companies to hit their targets with liquid additive packages. That leaves an opening for aftermarket companies to sell MOS2 and various competing chemistries directly to the small percentage of car owners who will pay extra for it. That's a real market gap, not a suppressed miracle cure. Independent labs have actually put these products through standardized tests, and it's worth knowing what those tests measure because the claims on the bottle rarely match the fine print. The 4-ball wear test is the industry standard for measuring anti-wear performance. 3 stationary steel balls, 1 rotating ball on top, all submerged in the oil sample, run under controlled load and speed, then measured for the wear scar left behind. Smaller scar, less friction damage. The NOAC volatility test measures how much of an oil evaporates when held at high, sustained engine operating temperature, because an oil that boils off too easily leaves you running low and running hotter. Across independent comparisons using these 2 tests, the pattern that shows up again and again is this. MOS2's suspension additives tend to hold up reasonably well under both heat exposure and wear testing, performing close to or slightly better than plain oil. Viscosity modifier heavy stabilizers tend to thicken the oil noticeably, which can look like quieter engine in the short term but isn't the same thing as reduced wear. Some EP, chlorinated paraffin-style additives, show excellent wear numbers fresh out of the bottle but degrade significantly after heat cycling. None of this is exotic. It's just rarely explained before the sale. If you want to actually use one of these responsibly, here's the realistic version, not the miracle version. First, know your engine's condition. Additives are far more useful as a targeted fix for a specific symptom, like a noisy lifter, a slight oil consumption issue, or an older high-mileage engine with worn tolerances, than as a blanket upgrade for a healthy young engine. Second, check compatibility. Some MOS2 suspensions are not recommended for vehicles with particulate filters or certain turbo configurations, so read the bottle, not just the star rating. Third, dose it exactly to the ratio printed on the label. Overconcentration is the single most common way people turn a helpful additive into a viscosity problem. Fourth, add it at the beginning of an oil change interval, not the middle, so you get a full cycle of exposure and can fairly judge the result. Fifth, track something measurable. An oil analysis at your next change, a fuel log, a simple 0 to 60 timer. Because seat of the pants impressions are exactly how these products get oversold in the first place. Now, the honest limitations, because a channel like the Hidden Fix Lab only stays useful if it tells you what it doesn't know too. No aftermarket additive reverses existing mechanical wear. A scored cylinder wall or a worn bearing stays worn. Independent lab testing on these categories, while real, is still bench scale. It does not perfectly replicate the combined heat, pressure, and combustion byproducts of a running engine over tens of thousands of miles, and results can vary by base oil, by engine design, and by how the additive is blended. If your engine already has a healthy oil, a reasonable change interval, and no specific symptom you're chasing, the honest answer is that a quality full synthetic oil on its own is probably doing more for your engine's lifespan than anything you could pour into it afterward, which is really the bigger lesson here. The additive aisle sells certainty, a can, a claim, a 5-star rating. Real engine longevity is quieter than that. It's regular oil changes, a filter that actually gets changed with it, and paying attention before a small noise becomes an expensive one. The chemistry in that $11 bottle is genuine. What you do with it, and whether you needed it in the first place, is the part we're thinking through before you buy.